the cast diagram. Example 1. We're given the sine ratio for angle x, and angle x is obtuse, so it's in this interval between 90 and 180. So to work out the exact cosine and tan ratios, so we start off with a right angle triangle, and we represent the sine x ratio on this. So sine is opposite over the hypotenuse. So using Pythagoras' theorem, we work out the missing side, which is the square root of 5 squared minus 3 squared, and we get 4. And then from there we work out the cosine ratio and tan ratio. So cos x adjacent over the hypotenuse 4/5, tan opposite over adjacent 3/4. But what we don't know is whether the cosine graph was above or below the x-axis for obtuse angles, and likewise for the tan graph. We can use the cast diagram. We're looking at the second quadrant because we've got obtuse angles, so we're in here, and the letter S is telling us that only sine is positive, which means we need to put a minus in front of these ratios for cosine and tan. Example 2. So tan x is equal to 3, and x is a reflex angle. It's in the interval 180 to 360 degrees, and the tan ratio given here is positive. So to represent this on a right angle triangle, we need two values, because tan is the opposite over the adjacent, so it's 3/1. On a right angle triangle, so we're looking for the longest side, so 3 squared plus 1 squared gives us 10. Let me square root 10. Now we can work out the exact ratio for sine and cos. So we have these ratios. Now we look at the cast diagram to work out the sine of each of these ratios. So reflex angles are here in quadrants 3 and 4, but our tan ratio that was given had a positive ratio. So we're confident that our angle is in quadrant 3. So in quadrant 3, only tan has a positive ratio. That means the cosine ratio is negative and the sine ratio is also negative. Example 3. So we're given the cosine ratio. Now to draw a right angle triangle, we're not going to put any minus values on any of the sides of the triangle. It wouldn't make any sense. So we ignore the minus completely, and we do the right angle triangle like this. So cos x is the adjacent over the hypotenuse, so we work out the missing side, so we get 3/5, and then we can work out the exact sine ratio and exact tan ratio from this triangle, and we have these values. And now we use the cast diagram, and for angles between minus 270 and minus 180, so that's 0 for negative angles going clockwise, minus 90, minus 180, minus 270. So we're in quadrant 2. Only sine has a positive ratio. So cosine and tan should both be negative. Well, cosine is negative, but tan must also be negative, but this one was positive. For practice, try these questions.